You know that feeling? Every single day, millions of us rely on a dark, bitter liquid to kickstart our mornings, push through those brutal afternoon slumps, and fuel our late-night focus. But beneath the surface of that warm, comforting mug lies a completely fascinating, invisible world of chemical warfare, and it is happening right inside your brain. In this explainer, we're going to peel back the layers and uncover exactly how the world's most popular drug physically manipulates your nervous system.
Part 1. The world's most popular drug.
100,000. That's the staggering number of metric tons of caffeine we humans consume globally every single year. Obviously, we're drinking it in our morning coffee and tea, but it's also hiding everywhere else. It's in sodas, chocolate, caffeine pills, and remarkably, even in beverages distinctly labeled as decaf. It is absolutely everywhere, quietly helping us feel alert, focused, happy, and energetic, even when our bodies are practically begging for sleep. To put that massive figure into perspective, if you took all the caffeine consumed worldwide in a single year and put it on a giant scale, it would equal the physical weight of 14 Eiffel Towers. Just think about that for a second. That is a monumental amount of a microscopic chemical being pumped into human biology year after year. Part 2. From plants to your brain. So where did it all start? Well, out in the wild, caffeine is actually a powerful botanical weapon, and it has this totally fascinating dual nature. It's naturally found in the leaves and seeds of certain plants, and in high doses, it's highly toxic to insects. It literally serves as a lethal defense mechanism. But nature is incredibly clever. When insects consume it in lower doses, like the tiny amounts found in a plant's nectar, it acts as a memory aid. It actually helps these insects remember and revisit those specific flowers, which obviously aids the plant in pollination. Which brings us to a really fun biological mystery. How exactly does a chemical that evolved as a literal bug spray for plants function as a powerful central nervous system stimulant in the human body? How does this botanical defense mechanism manage to so perfectly hack our human biology just to keep us awake? Part 3. The microscopic receptor battle. To understand this battle, we first have to understand the target. Meet adenosine. This is one of your body's key sleep-inducing molecules. You can kind of think of adenosine as your body's internal timer. It's the signal that tells your brain it's finally time to power down and rest. Let's walk through exactly how this natural sleep pressure builds up throughout your day. Your body needs a constant supply of energy to survive, right? It gets this energy by breaking down a high-energy molecule called ATP. Now, during that breakdown process, it liberates adenosine from ATP's chemical backbone. And here's where it gets interesting. The neurons in your brain possess specific receptors that are perfectly tailored to fit this adenosine molecule. When adenosine docks into these receptors, it triggers a chain reaction. It causes your neurons to fire more sluggishly and slows down the release of important brain signaling molecules. The end result? You feel sleepy. But then, caffeine enters your bloodstream, and this brings us to the imposter. In scientific terms, caffeine is what's called an adenosine receptor antagonist. That basically means it's a substance specifically designed to interfere with or totally inhibit the physiological action of adenosine. It's like a microscopic game of musical chairs. Caffeine and adenosine share a strikingly similar structure. They are close enough in shape that caffeine can successfully wedge itself right into those exact same adenosine parking spots on your neurons. But the fit isn't quite perfect enough to actually activate the receptor. So caffeine just sits there, blocking the spot and successfully derailing your brain's natural process of slowing down. It all boils down to this absolutely crucial concept. Adenosine inhibits your neurons. Caffeine inhibits the inhibitor. That is the core secret of the world's most popular drug. Caffeine doesn't magically create net new energy out of nowhere. It creates stimulation by effectively cutting the brake lines in your brain, stopping the natural sleep signals from ever taking hold. Part 4. Superpowers and side effects. Now, this microscopic blockade has some pretty wonderful secondary effects. The adenosine receptors in your brain are physically linked to receptors for another very famous molecule you've probably heard of, dopamine, which promotes feelings of pleasure and motivation. Normally, when adenosine docks, it makes it harder for dopamine to fit into its own spot, which interrupts its mood-lifting work. But when caffeine steals adenosine's parking spot, it doesn't have that same blocking effect on dopamine. Dopamine slides right in seamlessly. And that's exactly why your morning cup of coffee doesn't just wake you up, it actively boosts positive feelings and sharpens your focus.
And the science shows that a regular coffee habit actually goes way beyond a temporary morning buzz. There's real evidence linking caffeine's effects on these receptors to some surprising long-term health benefits. It has been shown to reduce the risk of neurodegenerative diseases like Parkinson's and Alzheimer's, as well as certain types of cancer. On top of that, caffeine acts as a physical enhancer, literally ramping up the body's ability to burn fat.
In fact, its physical enhancements are so potent that major sports organizations historically feared it provided an unfair advantage. Get this, from 1972 all the way to 2004, Olympic athletes were actually forced to stay below a strict blood caffeine concentration limit just to compete. It took over 3 decades for the Olympics to finally drop those strict limitations.
But look, as with any powerful chemical intervention, there is a dark side. We have to remind ourselves that this potent stimulant carries significant costs. Blocking your brain's natural rhythms can raise your heart rate, elevate your blood pressure, cause increased urination or diarrhea, and heavily contribute to both insomnia and anxiety. It's a really delicate biological balancing act.
Part 5. Tolerance and the crash. So why do we crash? And why do we always seem to need more coffee to get the same feeling? Here is how your brain mounts a clever but pretty punishing adaptation to constant caffeine exposure. Step 1. Your existing adenosine receptors are perpetually clogged by your daily coffee habit. Step 2. Your brain realizes it isn't getting the sleep signals it desperately needs, so it literally manufactures extra adenosine receptors to compensate. That's why your tolerance goes up. You actually have more receptors to block. Step 3, if you suddenly quit, all those extra receptors are left totally empty and wide open. Step 4, brutal withdrawal kicks in. When that happens, your natural adenosine goes to work in absolute overdrive. It hits you with a massive wave of fatigue, pounding headaches, extreme tiredness, and distinctly depressed moods, all because your brain is desperately trying to signal you to power down. But hey, the human body is incredibly resilient. If you can just survive those initial days of withdrawal, your brain will readjust. Without the constant flood of caffeine, it realizes it no longer needs that extra army of receptors. In a few days, they simply disappear. Your biological baseline resets, and you'll find you feel just as alert naturally, entirely without the infusion of the world's most popular stimulant. So I'll leave you with this thought. Tomorrow morning, when you reach for that next cup, ask yourself, is your coffee truly a tool for enhanced productivity? Or have you simply built an army of extra adenosine receptors that you are now forced to fight off every single day? The microscopic battle continues.